Hi everyone. My presentation today is about quality assurance with Scala. But first, let me start with a quick introduction. My name is Roch. I work as a Scala developer for Delsalle. We are a French mobile advertising company based in Paris. We have offices in London, Rio, and Berlin. When I joined the company about a year ago, we decided to move the entire platform from PHP to Scala. In fact, we needed to sustain heavy volumes of data, and as part of our stack, we decided to use Play Framework along with graph databases such as Python, and backed with Cassandra. Scala is de facto our CTO's first choice for the backend APIs, not only because it will help us deliver the best quality, but also because it's a statically typed language, and so we went for this choice. In advertising, like in many other industries, when you lose customer, they might not come back, so this is why we really wanted to stress on quality. That leads me to today's topic, quality assurance with Scala, with the following basic question. What is quality assurance? How can you use it on your current project? And you will see that QA is not only for big companies. There are plenty of open source tools available, and you can use them on your project. Be aware this talk is not going to be very technical. It should be easy to understand for everyone. And the idea is to give you some tips and feedbacks on my experience with QA, and I hope you enjoy it. I will try to be as precise and concise as possible. So, first, let's start by defining what is QA. Quality assurance is the automation of quality check tasks. So you might ask yourself, why is it worth it? Well, simply because you don't want to keep, you want to keep your production out of any trouble. Of course, you can run your test on your local machine while you're working on it, but when you work in teams, the merging and the integration of each developer's changes can be painful, and for that, you might want to use some tools that can automate your process. When you work on big projects, the execution of the tests might take a while, especially with Scala. So, as we will see later, there are plenty of other things you can do with the automation of your process. The first important tool to keep in mind is CI. CI stands for Continuous Integration. These tools will help you automate everything. The most common way to integrate CI is to plug it whenever someone pushes code on the project, and it will run your tests and, for instance, deploy to Maven the package. There are a few available on the market, and I've tried 3 of them: Jenkins, Trace, and GitLab. Jenkins is great, but it's a bit heavy. You might want to keep CI to what it's really all about, like running things. Trace, on the other hand, is lightweight. It only does what you expect it to do. All you need is a small YML configuration file at the root of your project. And finally, GitLab is a lot like Travis. It's a self-hosted open source solution, and this is the one we ended up using with our project. Now that we've defined what is quality assurance, let's talk about the first metrics, code coverage analysis. First, to define code coverage, it is a measure of how much of your code is actually tested. So that's a pretty useful metric you might want to look at. Before I introduce the available tools, let's see what are the different kind of code coverage techniques first. Line level coverage, branch level coverage, and statement level coverage. Many code coverage libraries used to be line-based, and that's usually fine for verbose languages like Java. But when you want to instrument Scala code, it's a bit more complex. In fact, one line of code can include several statements. So line level coverage is no longer like by choice. As you can see in this example, if you test for age equal 18, you would get 100% line level coverage simply because that line has been tested. But that doesn't tell you if it has been entirely tested. In fact, there are two statements in this line, and if you want to test all of them, you will need to also test for age is bigger than 18, for instance. Now, let's face line level coverage and branch level coverage. By looking at the example we have here, you can see that the results obtained with linear code coverage will have tested 4 lines of code over 5. While branch level coverage will have only tested 50% because it goes in only one of the branches of your if statement. So, what is the main difference between branch level coverage and statement level coverage? From what we've seen in the past example, they look pretty similar. With branch level coverage, it's not only about how many statements you have tested, it's also make sure you have tested each possible condition. So in this case, we have tested for true conditions or 2 variables, but if we want to get to 100% branch coverage, we will need to test our 2 conditions against false. So, as these techniques give you complementary results, you can use them together, and they all give you different ideas of how much of your code is actually tested. If branch level coverage is properly implemented with Scala, it should support the following symbols: if-else statement, match statement, and partial function cases, and try-catch finally closes in order to go inside all the possible branches. Okay, so these are the code coverage tools available. Once again, there are a few options if you want to instrument Scala code. SCCT, Jacoco for SBT, and Scoverage are the 3 most popular ones. SCCT was essentially a line level coverage project, and it was no longer active. It had actually been given up upon about 2 years ago, but a few pull requests were showing great interest into this project, and it was the most popular solution at the time. So, as I just started working on Scala, I initiated a few pull requests and some releases because people were asking for statement level coverage while SCCT only supported line level coverage. It outlined the fact that SCCT was facing this main issue of being a line-level coverage, and it definitely needed a deep cleanup. So that's why Samuel Steffen started to work on Scoverage. It's actually a fork of SCCT, but he has removed a lot of its content, and it has been cleaned up a lot. It now supports statement-level coverage along with branch-level coverage, and it takes back pretty much the same features from SCCT. The only feature missing at the moment is report merging, and I hope someone will contribute someday on it. On the other side, Jacoco for SBT is a SBT plugin allowing you to use Jacoco, which is the Java code coverage library, with Scala. Jacoco uses a very different approach from SCCT and Scoverage because it's bytecode based, and we will see what is the difference now between AST and bytecode instrumentation. So with bytecode instrumentation, the code coverage has to be collected at runtime. For this purpose, Jacoco creates instrumented version of the original class definition. This process is happening on the fly using Java agents, and it works pretty well when you want to instrument Java code. But obviously, that's not what we're interested in. Unfortunately, it doesn't work the same way with Scala because Scala has a very different bytecode output. One Scala statement doesn't always generate one bytecode copy. Sometimes it does more. For example, if you do a match case symbol, it will do maybe 10 times that or even more. So the ratio between statement and bytecode is not something you should rely on, at least with Scala. If you're interested in the bytecode generated by Scala, you should check out this presentation by Takipi. It's pretty interesting, and you can find it on SlideShare. So, yeah, let me give you a quick example of the issue with bytecode instrumentation. Let's say you're using line-level coverage for this example, and you've wrote 2 lines of Scala, and for example, the first line compiles to 100 bytecode, and the second line compiles to 10 bytecode. If you've only tested line 2, you would only get 9% coverage, while it should really be 50% because you've tested one of the 2 lines. This is why Scoverage uses a completely different approach, the AST. AST stands for Abstract Syntax Tree. With Scala, you can go through a tree representation of your code, of the code of your project, and it checks for which statement has been tested. So the Scala compiler offers this nice facility, which you don't have with Java. One of the great advantages of Scoverage is its modularity. As we will see later, there are plenty of modules and plugins you can use. So, first, the code instrumentation plugins. The plugins you will use to import code into Scoverage. Scoverage should allow you to instrument any kind of Scala project, whether you're using SBT, Maven, or Gradle. There is always a plugin. Scoverage takes back this feature from SCCT and can easily replace it just by switching inputs, sorry. For the results outputs, there are actually 3 kinds of results you can get from Scoverage. The first one is HTML under the form of a nice dashboard with percentages and a detail of what part of your code is tested. The second kind of output you can get is XML. Scoverage generates the standard Covertura XML export. Although this format is line-based only, we decided to take it back in order to maintain maximum compatibility with the existing tools. This way, you can use Covertura plugins and still get your coverage into your tools. And finally, Scoverage comes with its own coverage format, which is XML-based also, but it also includes statement-level coverage, results, and branch-level coverage. Now that you know how much of your code is actually tested, let's focus on another kind of instrumentation, static code analyzers. They can be used to review your code and tell you whether it's clean or not. There are plenty available. The 4 most popular ones are Scapegoat, Find Bugs, Check Style, and Scala Style. Basically, it's here to warn you whenever the basic rules are not respected. Let's say you're using nulls, let's say you're using gets on options. Scapegoat is here to tell you and to list all these problems you have in your code. It can generate a nice output file during compile time. Of course, there are many other tools available, but I didn't list them. Okay, so that leads us to talk about code quality inspection now. Most of these reports you've generated using plugins can be accessed in your target compile folder. And it would be even better if we can centralize them into one tool to monitor the metrics and keep an eye on their evolution. Sonar is the exact tool you need for that, and it's actually open source, and it shows you how much of your code is actually documented, commented, and if your rules are disrespected or not. It also allows you to include your code coverage results. This way, you know if your technical debt is growing or not. So this is what it looks like. You get nice percentages and details about your coverage. Honestly, it makes sense in a large team, and maybe it's not so. It would rather undermine a 5-people team. But it's definitely a dashboard to centralize every data you have and keep an eye on the quality. Rado released a Sonar Scoverage plugin. You can use it for your project to include your Scoverage results. Basically, at the moment, Scala support for Sonar is not amazing. It's pretty difficult to include all the results of the different tools available, but that doesn't help you taking full benefit from it. So yeah, Rado's plugin comes as a great milestone, and I hope more will follow. This is one of the possible workflow you can use to keep an eye on the quality. And for our platform, this is the workflow we've picked. SBT and Scala for the backend, and JS for the front end. We are actually using SBT and Scoverage for the coverage. And on the JS front end, they're using Branch and Karma along with Jasmine. So these results are executed in our GitLab CI runner, and then they're being submitted to Sonar. Of course, Sonar is not the only option. There are many tools available you can use to include your results. Coveralls is one of them. It's just a small service like GitHub you can use to get your code quality. Some services like GitHub have integrated CI results in their user experience. For now, GitHub works with traders. Each time you get a pull request, it starts a build, and that helps you reviewing it faster. For instance, if the build failed, you will get a notice on the pull request, and it will warn you before you merge it. So yeah, that helps you a lot when you review pull requests, and I think it's a pretty successful integration of CI into a user experience. There is also a plugin for Jenkins. It doesn't work the same way. Basically, it makes a comment on the pull request, and it tells you whether it's passed or not. Industrialization is one of my favorite aspects of quality assurance. You can also use your CI runner to do any kind of things. I guess you're all familiar with Play Framework, API documentation. It's actually entirely generated by the Jenkins CI and automatically pushed to a Git repository. In our company, we generate JSON file with the results of our APIs, and this way front-end developers can develop code in local without relying on our APIs. Whenever something changes in the APIs, we update the JSON on the Git repository, and this way they are always up to date and they can work offline on the project without having to rely on anything else. Deployment is not something you want to automate entirely. Of course, you can script most things up into the CI. However, there are some tools available, and they will help you in the last step of the process. The most important part is being able to roll back. So Capistrano is one of the most popular tools. It's based on Ruby, but some people use it with the Scala project. You can use it to version your deployments and run your SBT builds on multiple servers. Another tool has been released by the UK online newspaper, The Guardian, as their own Scala deployment tool. It's split into two parts, Magenta and Riffraff. Magenta is basically the equivalent for Capistrano. However, it has been entirely developed using Scala. Riffraff is a graphical user experience you can use to initiate your deployment and manage the previous one. We haven't integrated it yet, but we are looking forward to using this as a deployment tool. Thank you. I hope this presentation has been helpful. Mr. Bell is always recruiting, so if you're interested, feel free to come and ask us. Any question?
Yes. Would you use any other metric than branch coverage? Does branch coverage something exclusive by branch coverage?
The question is, would you use any other metrics apart from branch coverage? You should use statement level coverage along with branch coverage with Scala, in my opinion, because they provide complementary results.
So are there things that are not covered by branch coverage that are covered by statement coverage, or do you think that the percentages will be off?
Basically, it's not exactly the same thing. Most of the time, statement level coverage will be higher than branch coverage, but it's always interesting to see the difference. I guess it's not always the case.
Yeah, branch coverage is the hardest.
Yeah. Any other question? Yes.
Try to use some new tools like Roch and
Yeah, I've tried it, but I didn't end up using it in the end. I think it's like it's a bit like the tool I talked about after cut coverage. So, what do you want to know about it?
the use of these tools can improve code quality.
Well, I think static code inspection can help you highlight some parts of your code you might have forgotten, but yeah. Basically, they're not going to help you instantly on a daily basis just after you write your first line of code, but sometimes you forget some stuff on the side, and they help you to keep an eye on the entire project. Any other questions? Yes.
Yeah, we use Sonar at ING Bank, and your feedback is always very late. We have a hook in a pre-push hook, which tests our JS code with JSIN and Karma, all the things, and you cannot push unless your code is valid. It's validated. But Sonar is after you push and Jenkins pulls. So it's very late in the process. Do you have the same experience, or do you have a setup which allows you to signal things very fast?
Well, basically, the more we add tests, the more slow it gets, obviously. But the good thing is the fact that it runs in the background, so we don't have to worry about it. And we might get delayed results, but most of the time we don't look at them right after we push code. So I think it's not very important, but it's true. We get very slow builds. But
it's hard for ownership of large teams. When someone pushes to master or whatever that branch is doing, and then you get the report back 5 minutes later, and then the people are already doing something else, and someone goes, someone else did it. So it's hard for ownership.
yeah. Basically, if you work with a branch and pull requests, then everybody gets separate builds, and it helps seeing. I mean, you get a better idea of what people are doing, but it's more difficult, yes. Yes.
Why did you consider the use of Sonar suited more for the bigger needs of maybe smaller teams?
Because it takes some time to set it up. It's not always the biggest priority when you are in a small team, and I mean, to get it right, it will take time. I mean, if you want to take useful output from it and to get all your tools inside Sonar, then it's a lot of work.
I did a small team, 5 people actually, exactly.
We are 10 at the moment.
Yes, but I did it on this 5 people team, and yeah, it was sort of difficult actually.
Okay.
And it really helped.
Was it with Scala?
It's for that.
Yeah, that's the thing. I mean,
For Scala,
Sonar was initially made for a Java project, I think, and the support for this language is amazing. But when you go to Scala, it's entirely different. So there isn't much at the moment, and I don't think Sono's team cares a lot about Scala at the moment. Yeah. Any other question? Okay. Thank you.
We are going to do this very fast because now it's time to leave. So we want to thank you, all of you here. Obviously, there is not, so everybody is not here. Thank you for joining ScalaIO 2014. It was a real pleasure. We have two special gifts, two books for you guys if you want to win. So how would you do this? Do it fast.
They have nothing to do with Scala.
Yeah. So yeah, we want the book about Erlang. Who knows Erlang? Yeah, you guys, you want this book. And okay, you want the right to